Chapter 3, States of Matter, 3.1, Solids, Liquids, and Gases. A carpenter's level made of metal or wood has at least one transparent tube filled with clear liquid such as rubbing alcohol and an air bubble. When perfectly level, the bubble should be directly in the center of the clear tube. The three states of matter are represented by this level because at room temperature most metals are solid, alcohol liquid, and air gas. Materials can be classified as solids, liquids, and gases based on whether their shapes and volumes are definite or variable. Shape and volume are clues as to how particles within the material are arranged. Solids have a definite shape and volume, are familiar or recognizable shapes. Shape and volume won't change when moved. Changing the container does not alter the shape of the volume of a solid, and a shape or volume can be altered. If you order soup in a restaurant, the bowl or cup size can be deceiving. They may be very close in size, but the bowl costs considerably more. Our eyes cannot accurately judge volume in such cases because it is purposefully designed to increase profits for the restaurant. Liquids have the same shape as their containers. It can be poured from one container to another and has a definite volume, but not shape. At room temperature, mercury is a liquid. On a flat surface, the drops have a round shape. Mercury was used in thermometers for a long time because it remained liquid over a wider range of temperatures than water. Also, it was easy to read dark silver colors against the stark white background, did not stick to the glass, and has a thick, uniform consistency. The EPA, or Environmental Protection Agency, convinced people to replace them because mercury can cause respiratory, also known as breathing issues, and nervous system issues when glass thermometers break. Of gases. It takes the shape and volume of its container. Party balloons are filled with helium. Hybrid hot air balloons are filled with helium or hydrogen in the upper portion and heated circulating air, which we breathe, because helium or hydrogen is lighter than air and will remain in the upper part of the balloon until it is released. Helium atoms are spread further apart than neighboring mercury and copper on the periodic table. Due to that space, it can be compressed into a metal cylinder, spreading out again as soon as it is released. Other states of matter on Earth, almost all matter exists in solid, liquid, or gaseous state. 99% of matter is not seen on Earth. At extreme high temperatures, like the stars, including our sun, matter exists as plasma. We'll discuss this more in Chapter 10. Einstein accurately predicted that there is a fifth state of matter in extreme cold temperatures called the Bose-Einstein condensate, or BEC. The energy an object has is due to its motion. The faster the object moves, the greater the kinetic energy. Particles both inside and outside the object are moving when the object is moving. In pool, the white ball is struck by the cue stick, colliding that ball with solid and striped balls. Motion of pool or billiard balls is kinetic energy transference. It can be compared to the motion of particles in a gas. Kinetic energy is transferred during collisions. Particles of gas are never at rest. They are in constant random motion. Movement is not one speed for all particles. Forces of attraction happens between particles. Motion of one particle is unaffected by another unless, of course, they collide, like in our example of the pool balls or billiard balls. And constant movement among gas particles causes filling of a gas container of any size. Under ordinary conditions, scientists can ignore the forces of attraction of gases. Particles are more closely packed than those in gases when we're talking about the behavior of liquids. They are in constant movement. The forces of attraction limit the motion of particles in a liquid. The particles in that liquid cannot spread out and fill the container. Attractions between particles can affect movement of other particles. Take the shape of their container because particles flow to new locations. And volume is constant because forces of attraction keep the particles close together. If you check out the photo, cars are closely packed like they are in our Chicagoland traffic. Movement is very dependent upon other drivers in cars and trucks. Paths are often blocked by multi-vehicle accidents, especially those of us that travel 80/94. Overturned trucks, lane closures, especially this time of year and in construction. And just like the laws of attraction preventing liquids from spreading out inside a container, the highway may have open lanes that the drivers just can't reach. Solids have a definite volume and shape because particles in a solid vibrate around fixed locations. Vibration is a repetitive back and forth motion. Each atom vibrates around its location, but it does not exchange places with neighboring atoms. If we look at the photo, particles of a liquid behave like concert goers coming out of a stadium. They are tightly packed and dependent upon the movement of people in front of them. This bottleneck behavior is similar to that of solids. For your 3.1 assessment, please continue to handwrite your work. We are focusing on the 3.1 Introduction to Solids, Liquids, and Gases. And then in the next video set, we're going to talk about individual gas laws, in addition to an overview of that section 3.2, before we get to the assessment. All right, number 1, how are shape and volume used to classify solids, liquids, and gases? 2, what does the kinetic theory say about the motion of atoms? 3, how is a gas able to fill a container of any size or shape? 4, use kinetic theory and attractive forces to explain why a liquid has a definite volume and a shape that can vary. 5, explain why a solid has a definite shape and volume. 6, how does the arrangement of atoms in most solids differ from the arrangements of atoms in a liquid? Number 7, explain how the behavior of popcorn in a popcorn popper can be used as an analogy for the motion of gas particles. And number 8, a hazardous chemical is leaking from a tank truck. Rescue workers need to evacuate people who live near the accident. Why are more people likely to be affected if the chemical is a gas versus a liquid? Please be careful and take your time working on your assessment questions. If you answer them correctly, this will help you to prepare for a successful attempt at a mastery check.